We're going to be going through a SAT math no calculator section. The Mathochist way. Let's just dive in here. This is practice test number 10. Just see what happens over here. Number 1, what value of z satisfies the equation above? Oh, they love to start us out nice and simple. Well, I'm gonna subtract this z here to the other side of the equation. So first I'm gonna start by rewriting the equation out. I know that this is an easy question, and I know that I'm gonna get some hate in the comments for doing this, but I'm gonna rewrite this z as 1z, by the way. Kind of a nice, prophylactic measure I'm taking here. A lot of times when you're moving quickly on these sections, and especially in these easy questions, you're not really doing the good preventative measures, taking the good preventative measures, idiom for you there, that are going to help prevent those silly mistakes from occurring. I'm not going to go into a big rant about silly mistakes here. I have other videos about that. Okay, now what I'm going to do, I'm going to bring the 1z over to the left, minus 1z to both sides. So 2z minus 1z is just 1z, or z. Now I have z plus 1 equals 0. And you can probably see where this is going, right? Minus 1 to both sides. Z equals -1. Okay. Again, I know that that's an easy question or whatever, but I'm trying to demonstrate for you the good habits that are important to have so you don't make those silly mistakes that keep mystifying you. Okay, number 2. A television with a price of $300 is to be purchased with an initial payment of $60. Okay. Let's just take a moment here. I just want you to notice this. Initial payment of $60. Now, let's take a little peek at the answer choices down here, right? Notice what these look like. These should all scream out to you y equals mx plus b, okay? I know that there's no y or x over here, but the w is doing the x thing. The point is, there's no exponents on the variables over here. It's a linear equation, and they tell us that the initial payment is $60. Now, I don't like to jump to conclusions or anything, but if this is number 2, probably all they're going to be asking us is which equation matches this situation. They're not going to do something super tricky this early on. Initial payment of $60. That means that the 60 is the y-intercept. Okay? It's the starting value. So the way that shows up in the equation is it's the constant, the number by itself, in the sense that it's the number that's not touching a variable. So we can get rid of d, right? Because, look, it's 60w, that's being a slope. We can get rid of b because the 60 is not even mentioned there. Now let's see. Oh, and they said it was an initial payment of $60, didn't they? They didn't say it was an initial payment of -$60, so we can get rid of the a as well. I guess c is our only option. Let me just go ahead and read the rest of the question just to make sure I didn't, wasn't too hasty. Weekly payments of 30. Okay, that makes sense because 30 W's all over the place. Weekly, by the way. Weekly, that's one of our slope words. Have you seen my video about slope words? You see a reference to how often a change occurs or something like that? That's almost always going to be slope. Remember how much they love slope on this test? Okay. Which of the following equations can be used to find the number of weekly payments W required to complete the purchase, assuming they're... Okay, what a surprise. They were asking us which equation matches the situation over here. Let's check out this next one, number 3. Okay, now before I even read this question, I want to point out to you, look what we got. They give us a table of values, and they give us equations in the answer choices. So, all they're going to be asking us here is which equation fits the data up here, okay? I'll read the question because I don't really like to advocate not reading questions because that can be dangerous. And, as we can see over here, I like to be safe. I wrote out for goodness sake, look at the steps I wrote out for number 1 over here. Obviously, I like to be safe over here because the goal isn't just so you understand the math. The goal is so that you can perform like you understand the math on test day. That's what counts, okay? You don't get points for understanding things in your bed, in the safety of your bed when you're hiding under the covers, okay? You get points for delivering a correct answer on test day when it counts. So that means we write our steps out. That means we read the questions, even though I don't want to, because I know what it's going to be asking. They're just going to be asking which equation matches the data. I'll keep reading. The table above shows shipping charges for an online retailer that sells sporting goods. There is a linear relationship. Yeah, look at these equations. They're all y equals mx plus b equations, aren't they? So, yeah. There's a linear relationship between the shipping charge and the weight of the merchandise. Which function can be used to determine the total shipping charge f of x in dollars for an order with a merchandise weight of x pounds? Okay. So, yeah. We got the table here. They're asking us which equation matches the table over here. Now, arguably, it's good to read the question carefully because we want to make sure that we know which column is which one's the x, which one's the y, or the f of x, but you know that's the same thing, right? Y and f of x. And they told us x pounds, so the pounds over here, so that's the x, and the shipping charge f of x, so we know that the shipping charge here is the f of x. But in questions like this, in tables like this, the x is going to be on the left, and then you're going to have the f of x. That's sort of just the convention of input-output kind of tables. But it's not a waste of your time to read thoroughly to confirm that. Now, there's different ways people have of doing this. Let me tell you the way we're not going to do it. What we're not going to do is use the data up here to calculate the slope. That seems very challenging and annoying in a no calculator section. Look at these decimal points over here, right? What we're also not going to do is go to the first row and think, oh, 1694 is the first, thing they told us. So that means that's the y-intercept. So I should probably pick D over here, right? Because look, that's the one with the y-intercept of that. First of all, y-intercept doesn't just mean the first thing they told you. It means the thing when x is 0. X is not 0 over here. We're not going to be doing any of that. What we're going to be doing is what I want you to always do when you're in a situation like this. And here's what I mean by a situation like this. I mean, they give you data above the question and equations in the answer choices. And by data above the question, I mean a table of values like this, or a graph. Maybe they have a line on a graph, or a parabola on a graph, or some curve on a graph that you can pick points out of. Point is, we're going to pick values out of the data and plug them into the equation. That's always what we're going to do. And which of these values of x do you think is going to be the easiest number to plug into these equations down here? 5, 10, 20, or 40? Yeah, we're going to be doing the 10, because to multiply something by 10, all that happens is you add a 0. Or if it's a decimal thing like down here, we're just going to move the decimal over to the right. So according to this table, when x is 10, f of x is 21.89. Let's go down into the answers. Choice A. If we move this decimal over to the right, A becomes 9.9. That's not 21.89, so I'm crossing that out. Choice B. If we move decimal over, it becomes 9.9 plus 11.99. That sounds like it could be 21.89. I don't know. I'll leave it in. I'm not going to waste time figuring it out yet. Choice C, if I move the decimal over to the right, it becomes 33.9 is what it becomes. 33.9. It's not 21.89, so I'm crossing C out. And D is going to be even wronger than C, because D is going to take the 33.9 and add that 16.94. We would identify this as a trap answer, though, right? Because remember they tried to use that 16.94 up here to make it seem like that was the y-intercept? Whatever. So D's out as well. And look, we don't even need to do the work to figure out if B indeed adds up to 21.89. I'm just going to go ahead and circle that right now because you're the only one left. I mean, you know that about the math section, right? That if we only have one answer choice left, we are done. Don't play that game in the verbal part and the reading and writing sections. Don't just act like you crossed out 3 so you're done. In the math section, it does mean that, though. Okay, so number 4 over here, we got a graph with a line. The line in the xy plane above represents the relationship between the height, h of x in feet, and the base diameter x in feet for cylindrical Doric columns in ancient Greek architecture. How much greater is the height of a Doric column that has a base diameter of 5 feet than the height of a Doric column that has a base diameter of 2 feet? Okay, how much greater they're saying in the question? That means we're going to subtract one thing from another. That's what that means. Let's see. They want to know how much greater is the height of stuff. Height, as they say, is the h of x, meaning it's the y value. And they say base diameter of 5 versus base diameter of 2. We also know the base diameter is the x. So they tell us base diameter of 5. We go to the x of 5 up here. So it looks like that y value is 35. And they say base diameter of 2. That's over here. That's a y value of 14. We're going to subtract these two numbers, huh? 5 minus 4 is 1. So we know the answer is going to end in a 1. And look at the answers. Only one of them ends in a 1. So I'm picking it. Now, it wouldn't take more than a second to finish this subtraction and do 21. But I just want to demonstrate that to you as a time-saving technique to get used to doing. We want to take advantage of the multiple choiceness of a test like this. Does that make any sense to you? Ugh. Okay. Number 5 over here. If x is positive, I always pronounce this kind of stuff in English. When I see x is greater than 0, I say positive. When I say x is less than 0, I say negative. It helps my brain more understand what's happening, the more words I use in my brain. I don't know if you're like that or not, but I like to think in words. Okay. Which of the following is equivalent to the given expression? Well, let's see here. Let's just break it down a little bit. We have a square root over this whole thing. 9 is in there. The square root of 9 is 3. So I'm crossing out anything that doesn't have a 3 in it. The square root of x squared is x. So I'm going to go ahead and circle A. 3x. Now, I could also just make the point that, well, x squared is under a radical. So something's going to happen to the x squared, so it can't be b. Because it isn't like nothing's going to happen to it. It's under the square root. Okay. Number 6. What are all the values of x that satisfy the equation? Let's see here. First, let me make some room for me. Now, I want you to look at the ingredients they gave us here. You know how I like to talk about that? The ingredients in these questions. X squared minus 1 over x minus 1 equals negative 2. When you see something like this up here, x squared minus 1, there's something you should already be thinking about. You know what I'm talking about? It's the difference of squares. You ever hear about this? A squared minus b squared is a minus b times a plus b. Is that like something you know about? It is something the SAT cares if you know or not, okay? They want you to take a look at, be able to take a look at the ingredients of the difference of squares. Sometimes they'll give you this part. Sometimes they'll give you this part and this part. Sometimes they'll give you this part and this part. Sometimes they'll give you all the parts. But they want you to be able to see these ingredients and recognize the difference of squares is going on. So x squared minus 1 is a difference of squares, right? Because x squared is obviously the square of x, and 1 is the square of 1. I should probably do a video about the difference of squares. This becomes x minus 1, x plus 1. So let's immediately apply that difference of squares to this expression over here. They say x squared minus 1 over x minus 1 equals negative 2. I'm going to write x minus 1, x plus 1 over x minus 1 equals negative 2. Now, you know how I like to take advantage of the multiple choiceness of this test. There's an answer we can get rid of right away, right? Look at those choices. I don't want you to just be holding off on looking at the answers until the end of the problem, by the way. That's what we do in the reading section, admittedly. In the reading section, I do want you to basically pretend the answer choices aren't even there while you're doing the question. And then at the very end, when you have your answer, that's when I want you looking at those answer choices. But in the math section, no. We incorporate those into our process from the beginning. We got a denominator. We got a denominator over here, right? And what's the one thing a denominator can't be? It can't be 0. Yeah, correct. So look at this denominator. What would make this denominator 0? 1. So definitely C is not going to be the answer. That doesn't satisfy the equation. That satisfies nobody. Unless they asked us something like, what would make this equation undefined? Which they are very capable of asking, by the way. Anyways, check this out. X minus 1 gets canceled out with that x minus 1. So now we're just left with x plus 1 equals negative 2. And then minus 1 to both sides. Boop. We're left with x equals negative 3. And look, that's the answer up here. Isn't that nice? Now, it always helps to be aware of about where you are in the section. So we're in the first half of the multiple choice right now. Do you know how many questions are even in this no calculator section? There's 20 questions total, but as far as the multiple choice is concerned, there's 15 multiple choice questions. And then we have the 5, 16 through 20 student-produced response questions, the non-multiple choice ones. Now, both parts of the section, the main part, the multiple choice, and then the non-multiple choice, both parts of this section have their own arc of easy to medium to hard questions. So the multiple choice goes easy, medium to hard up until number 15, and then we start back with easy mode at number 16, and 16 through 20 goes up to hard again. So it really is important for you to be aware of where you are in the section. If we're on number 6, we're still in the first half of the multiple choice. So we're not really that worried about things being super sneaky yet. But we're getting close to the second half. And I always advocate for when things get annoying in the multiple choice, skip to the non-multiple choice because, one, there's more easy mode questions there, and it's a better use of our time to be attacking all the easy mode ones first, because super hard questions can drain our time, drain our energy, and of course we have to get to those, but we're going to be in such a more comfortable place mentally, emotionally, to handle them if we know in our hearts that we've already handled all the other questions. Doesn't that make sense? Don't let your anal, compulsive desire to do everything in proper order lower your score. Okay? What do you care more about? having a higher score, or doing everything in order? Okay? And it is, you are choosing between them. Don't think you're not. Okay, the graph of y equals f of x is shown in the xy plane. What is the value of f of 0? F of 0. I did a video about this recently. All the different things that should make you automatically think of y-intercept. F of 0 means when x is 0. That means we're looking at the y-intercept. That means we go to the y-axis. We see where this curve hits the y-axis. I guess I already had it marked there. It's 4. Boom. We're done. I'm moving on. Number 8. In the figure above, point B lies on AD. What is the value of 3x? Now look at what's happening already. So this is the beginning of the second half of the multiple choice. So I'm just going to start to get a little bit more cautious. But notice what they're already throwing at us. The value of 3x. Compare that to what they did with number 1 back here. They just want to know what the value of z was. Or number 6, the values of x. Simpler times, right? As we continue in the section, they're going to start to throw more curveballs at us like this. So what I would say is to get increasingly paranoid as you move through a math section. So when you're in the second half, you want to be suspiciously looking around for traps. And the easiest trap to train your brain to look for is the question trap. Look at what question they're actually asking you here. Double check what question they're asking you before finalizing your answer. Because sometimes you notice what the final question is asking you. You do the work, but then you kind of forget because doing the work kind of like sent your brain off in another direction. So get in the habit of double checking what they were actually asking you before you bubble your answer on the answer sheet, okay? When you're in the second half. The first half, we don't need to worry about that stuff too much. They don't really throw those kinds of curveballs at us like this. Okay, well, I think you can probably see what's going on here, right? AD is a line. This is a right angle. That means that this whole part is a right angle. That means all three of these angles add up to a right angle, add up to 90. So we can just set up that x plus 2x plus 2x equals 90. 2x plus 2x is 4x, 5x equals 90. I'm going to give you a few ways to figure out what the answer is from here. Because remember, there's no calculator here. 1, we could set up a long division. 90 divided by 5 wouldn't be too bad. Well, we could say, well, I know that 90 divided by 10 is 9. So that means that there's 10 9s inside of 90. So how many 5s are there inside of 90? Well, there's going to be twice as many, aren't there? Because 5 is half of 10. So twice as many than 9. So 18. And here's my favorite way of knowing. It's going to be 18 because look at the answer A. Of course they're going to have a trap answer here for 3x. I mean, they're asking for 3x, so there's going to be a trap answer in there. They're just asking for regular x. And now they want 3x, so I'm going to do 3 times 18. 3 times 8 is 24, so I know the answer ends in a 4. And look at the answer choices. Only one of them ends in a 4, so I'm moving on with my life, okay? Which of the following is an equation of line L in the xy plane above? Now, once again, there's different things we could do here. The broke way to handle this would be to observe this line, calculate the slope, figure out the slope, observe the y-intercept, create a y equals mx plus b equation, then get all of these equations into y equals mx plus b form and figure it out from there. Just match up which one's which. That's fine. But you know what? No, it's not fine. Because what did we just talk about? We just talked about how when they give you data, And equations in the answer choices, you're going to be picking a point from the data and plugging them in to each answer choice. Okay? That's it. And I think a great place to start is with the intercepts. So how about this one? We know that this is the point -4. I always have such a problem with 4s on this. -4, 0. So the -4 is the x and the 0 is the y. Let's look at these answers here, right? -4 minus 0 is -4, so A works. It doesn't prove that it's the right answer. We use process of elimination when we do this, just like with that one with the table earlier. B, -4 minus 0 is not +4, so we cross out B. Choice C, -4 plus 0 is -4, so C can live for now. D, -4 plus 0 is not +4, so we cross out D. Now let's go to the other intercept. This one is 0, -4. So now x is 0 and y is -4. A, 0 minus -4. Well, that's like saying 0 minus -4. That's like saying 0 plus +4, right? You know about that, right? The two negatives make a positive. That equals 4, not -4. So we cross out A. And oh, look, C is the only one left, so I'm picking it and moving on with my life, okay? 10. Wow, look at this. I just see a parabola, and I see the y-intercept marked as k. Let's see what happens. The graph of y equals 2x squared plus 10x plus 12 is shown. If the graph crosses the y-axis at the point 0k, what is the value of k? Again, with the y-intercept stuff, all y-intercept means is x is 0. You can even observe that on the graph. You can even observe it in the point they give you. X is 0. Put 0 in for x. So instead of 2x squared plus 10x plus 12, it's going to be 2 times 0 squared plus 10 times 0 plus 12. And guess what? 0, this goes away, this goes away. Of course, we're just going to be left with the 12. Because, by the way, that's where the y-intercept always is when they give you a quadratic equation in standard form. I didn't even need to do all this stuff. I don't know why I did it. They gave us a quadratic equation in standard form, so we know the y-intercept's right there. Sorry for wasting your time. A circle in the xy plane has center 5, 7 and radius 2. Which of the following is an equation of the circle? Okay. I don't know if you know how circle equations work, but it's like this. X minus h squared plus y minus k squared equals r squared. R is the radius. So they're telling us that the radius is 2. So for this equation, it should equal 2 squared. It should equal 4. So C and D are out. And of course, look at those traps, right? Of course, they have just the R there. So just by knowing that their circle equation equals r squared, already we've crossed out 2 choices, and now it's a 50-50 guess, okay? And also it's 5, so it should be x minus 5 and y minus 7, right? If it was -5, -7, then it'd be plus plus, because it'd be minus a negative. So just by knowing what the equation of a circle is, you get number 11 correct. Pretty solid. Okay, what's next? In the figure above, triangle ABC is similar to triangle DEF. What is the value of cosine E? Oh, I definitely did a video on this recently. So we have similar triangles. Remember that part of what it means to have similar triangles is that the side lengths are proportional. And part of what that means is all the corresponding trig stuff is the same. So they want to know the cosine of angle E. Angle E corresponds to angle B. So they're just asking for the cosine of angle B. And now we just got to remember SOHCAHTOA, right? SOHCAHTOA. We remember how that works, right? You know how this goes. The cosine is in this part, CAH. because it's the adjacent over the hypotenuse. So, for cosine of angle B, adjacent side is 12 over 13. Is that here? Yeah, it's B. Okay. Number 13. In the xy plane, the graph of the function f of x equals x squared plus 5x plus 4 has two x-intercepts. What is the distance between the x-intercepts? Well, x-intercepts is the same thing as solutions. You know that, right? Zeros, roots, okay? So let's just find the solutions of this. Let's start by factoring and see if that works. Otherwise, we're gonna maybe have to do some quadratic formula. X, what multiplies to 4 and adds up to 5? 1 and 4. Everything's positive in this equation, so they kept it pretty, chill for us, which is nice. That means that x equals negative 1 and x equals negative 4. Okay. So what's the distance between these two things? Well, you can either plot it on a number line and count it up, or you can remember that distance is like difference. Negative 4 minus negative 1, boop, boop, gets us negative 3. Oh, it's like the absolute value, by the way. Absolute value of the difference is the distance. There's no negative answers as an option anyway. So it's going to be 3. But, that's what absolute value is for, by the way, for distance of stuff. Okay, number 14. What are all values of x that satisfy the given equation? Okay, we got to get a bit more careful now, because remember what I said. We're almost done with the multiple choice section, right? Number 15, it only goes up to 15. Then it's the non-multiple choice. Then it resets back to easy mode. So we don't want to be doing anything too wild over here. We don't want to be doing this squaring both sides nonsense. Now, long story short, when they give you an equation with a square root in there, and you square both sides, you are fundamentally erasing a part of an essential part of the equation, because there's certain stuff that's not allowed to happen under a square root, right? For example, you can't have a negative under a square root. Now, can you? But if we square both sides and erase this square root, we're erasing that restriction from the question. So what you're technically supposed to do when you have a square root in an equation. Or, by the way, same applies to a denominator in an equation, because you also can't have certain stuff in a denominator. 0. What you're technically supposed to do is solve the equation, and then, with your solutions, plug them all back into the original equation to check and see if they actually work with the square root there. But on a multiple choice test, how about we just do that from the beginning? They give us the possible answers here, right? X equals 1. Let's try that. X equals 1. So that would be the square root of 4 times 1 is 4 equals, not x minus 3 anymore. It's going to be 1 minus 3. We can already see this is going wrong. Square root of 4 is going to be 2. 1 minus 3 is negative 2. Now, I can hear it already. Don't you dare tell me that, oh, the square root of 4 is actually plus or minus 2. No. No, it is not. When you see the square root sign on the page, the result is going to be positive. Okay? That's a square root is always positive. If you see square root of 4, that equals positive 2. Here's what you're thinking of. You're thinking of this. I'm going to write it down here. If I have x squared equals 4, I have an equation like that, and then to solve it, I take the square root of both sides, that's going to give me the plus or minus 2. But do you see the difference between these scenarios? Here we're saying what squared equals 4? Well, 2 squared equals 4. And negative 2 squared also equals 4. That's why the result is plus or minus 2. But if they say square root is specifically positive. So I don't want to hear that about how the square root of 4 is plus or minus 2. That's a convention of math. Just deal with it. Point is, this did not work. 2 does not equal negative 2. So that means that 1 is not a possibility. So I'm going to cross out anything that tells me that 1 is a possibility. Now I'm going to try the 9 because I guess neither is an option as well. So let's try x equals 9. It's going to be square root of 4 times 9, which I'll go ahead and write out. Why not? Equals 9 minus 3. This one looks more promising because 9 minus 3 is 6. 4 times 9 is square root of 36. The square root of 36 is indeed positive 6. So that means that 9 works. That means that the answer is B over here. Isn't that great? Okay, 15. In the system of equations above, A is a constant. For which of the following values of A does the system have no solution? Okay. We see the phrase no solution show up in a couple different ways on this test. Sometimes it shows up when they give you a single equation, and that's one scenario. Other times it shows up when there are two equations, when there is a system of equations, as they like to say. Now, what does that mean? To have a system of equations with no solution? Well, let me answer your question with a question. What does it mean for a system of equations to have one solution? Just think about this. Okay, so first of all, look at the equations. They're both linear equations, right? Can you recognize that? Can you admit that? There's no exponents on any of the variables, so that means that they're linear equations, okay? So when we graph them, they're lines. Now, what does the solution of a system of linear equations look like on that graph? What does it represent on the graph? It represents the intersection point. So, when a system has no solutions, that means it's two lines that don't intersect, which means they're parallel lines, which means they have the same slope. So all we're going to do is find the slope of each equation. Now, I hope you've seen my video about the slope shortcut, because when they give us linear equations in this form, in what's called standard form, which is ax plus by equals c, sure, we could rearrange it to get it into y equals mx plus b form, but if we know this handy slope shortcut, negative a over b, we'll just be able to calculate both slopes pretty effectively, right? The slope of the top one is going to be negative a, so negative 3, which is going to be positive 3, over b, which is 1. Okay, so it's 3. And then the slope of this one is going to be negative a over 2. And they're parallel lines, right? So the same slope. So we set them equal to each other. I'm gonna take a moment and rewrite this equation to make it a little nicer for me. First thing I'm gonna do is I'm gonna put the variable stuff on the left side. So I'm gonna write negative a over 2 over here. That's just easier for me to look at. Maybe if you're left-handed, it's different. And then positive 3 over 1, I'm just gonna call that 3. And I think you can see what's gonna happen here. I multiply both sides by 2. I'm going to get negative a equals 6. Oh, look at how sneaky they are, right? They put 6 as an answer. Because negative a is 6. We're too smart for that. That means a is going to be negative 6. So, system of linear equations with no solutions means they have the same slope. ax plus by equals c is a standard form of linear equation. When they give you that, the slope is just going to be negative a over b. That's how you make these questions go much more quicker by. Okay? Oh, let's go to the non-multiple choice now. Back to easy mode. A manufacturer shipped units, okay, of a certain product to 2 locations. The equation above shows the total shipping cost, T in dollars, for shipping C units to the closer location and shipping F units to the farther location. If the total shipping cost was $47,000 and 3,000 units were shipped to the farther location, how many units were shipped to the closer location? Okay, they gave us a big wall of text. I wasn't really listening to any of it, but it's number 16. Easy mode. So it's just going to be plugging stuff into this equation. We just got to be careful about how it works here. They said that the total shipping costs is, of course, T. All the letters line up here, right? Closer is C, farther is F. They told us that the total was 47,000 and then 3,000 were the farther. So how many for the closer? So basically, T is 47,000. Let's start plugging some stuff in here. F is 3,000, and how much is C? So equals 5C plus 12 times 3,000. Okay. Even though it's an easy mode question, I'm still going to treat it with the respect of writing out the steps. Because also now this is not multiple choice anymore. So we don't have that safety net to save us. So gotta be careful here. 36,000. And now let's just subtract 36,000 from both sides. All right. 7 minus 6 is 1. 4 minus 3 is 1. Equals 5C. Oh, boy. That's really annoying over here. Well, we can divide both sides by 5 to get C. But let's actually use that shortcut from earlier, right? Because 11,000 divided by 10, what would that be? Well, that would just be 1,100, wouldn't it? So 11,000 divided by 5, well, since 5 is half of 10, then twice as many 5s should be able to go into that, right? So if 11,000 divided by 10 would be 1,100, then 11,000 divided by 5 would be 2,200. That should be our answer there. It certainly should be. Let's just do a little check. 5 times 0 is 0. 5 times 0 is 0. 5 times 0 is 10. 5. I think I did it right. 0, 0, 5 times. Yeah. It's fine. 5 times 0 is 0. 5 times 0 is 0. 5 times 2 is 10. 5 times 10 is 11. That's what happens. We're good. 17. Absolute value of 2x plus 1 equals 5. If A and B are the solutions to the equation above, what is the absolute value of A minus B? Super simple situation over here. Absolute value equations becomes 2 equations. We make what it equals plus or minus. So we have 2x plus 1 equals 5, and we have 2x plus 1 equals negative 5. So let's see here. 2x plus 1 equals 5 minus 1 to both sides. That's going to give us 2x equals 4. So that means that x equals 2. Here, similar situation. Subtract 1 from both sides, but this time we get 2x equals negative 6. So that means that x equals negative 3. They want to know the absolute value of a minus b. A and b are the solutions. So a and b are 2 and negative 3. So 2 minus negative 3. And they want the absolute value of this. Well, 2 minus negative 3, once again, double negatives. 2 plus 3, that's the absolute value of 5, which is 5. So 5 is the answer, okay? Juan purchased an antique that had a value of $200 at the time of purchase. Each year, the value of the antique is estimated to increase 10% over its value the previous year. The estimated value of the antique in dollars 2 years after purchase can be represented by the expression 200A, where A is a constant. What is the value of A? Yeah. So we've talked about exponential change equations before. To increase by 10%. So first of all, it was 200 from the beginning, right? So remember how these equations are built? We have the starting value. We have the change in parentheses. And then we have some sort of exponent to represent how often the change happened or how many times the change happened, something like that. To increase by 10%. Well, 10% is like 0.1. So to increase by 10%, we multiply by 1.1. You remember that, right? So 1.1. And they said it happens 2 years later. So there's going to be a 2 over here. Now, they said that this can be represented by the expression 200A. And this is our expression. So the 200 is already here. So the A part must be this. The rest of it, the 1.1 squared. Well, we just got to do 1.1 times 1.1. And if you forget how to do this decimal multiplying in a no calculator situation, let's first drop the decimals and just treat it like 11 times 11. 11 times 11 is 121. Hopefully remember those times tables. And now let's bring the decimal places back into it. How many decimal places did we ignore before? This one and this one. That's 2. Let's bring both those places back in. 1.21. That's our answer there. Oh, I love these. Based on the system of equations above, what is the value of 5x plus 5y? Now, before you just go on to autopilot, multiplying the top equation by -3 and the bottom one by 2 and then adding them together so you can cancel out the x's, whatever. That's the trap way they want you to do a question like this. Okay? And here's the okay. If they're asking you to solve for like just x or just y, like individually, then fine, sure, okay, sure. Let's do it one of those classic elimination or substitution kind of a ways. But when they're asking you for some kind of weird expression like this, some kind of x plus y, x minus y expression, all you're going to do is just add the equations together as they are, or subtract one from the other one as they are, whichever one, works basically. So look what happens when we add these equations together. 2x plus 3x is 5x. 3y plus 2y is 5y. So we're going to get the answer right here. 1200 plus 1300 is 2500. Wow. So great. Okay. The final one here. If u plus t equals 5 and u minus t equals 2, what is the value of u minus t times u squared minus t squared? Wow. It's 2 in a row where they're trying to bait us into solving a system of equations in the classical way, right? Because look, they give us u plus t equals 5 and u minus t equals 2. So you might think that you want to, if we add these equations together, it eliminates the t, and then we can solve for the u, and then we can... Sure. If we did all that, and we didn't make any mistakes, and we had time to do all those steps, that would lead us to the right answer. Now, some traps are designed to lead you to trap answers, but there's no trap answers in this part, right? There's no multiple choice over here. Other traps are designed to just kind of waste your time and add a bunch of unnecessary steps to the process so that you make it more likely to make a mistake, right? The more steps we add to our process, the more we're increasing the chances of making mistakes. Look at what we have here. U plus t, u minus t, u minus t, u squared minus t squared. once again, we have the difference of squares, right? U squared minus t squared is u plus t times u minus t. That's just how your brain needs to be wired, okay? I'm sorry. Like, and I'm not saying if it's not wired like that yet, you're screwed. You just got to do that wiring now. You need to practice recognizing when they've given you the ingredients of the difference of squares. So u minus t times u squared minus t squared, that's just like saying u minus t times u plus t times u minus t. Just the same thing. So let's see here. U minus t, they told us is 2. U plus t, they told us is 5. And u minus t, once again, they told us is 2. So 2 times 5 is 10. 10 times 2 is 20. The answer is 20. So that's a no calculator section. I realized that we took a bit longer to do it than the time given for it. But before you write any comments about that, I'm doing a lot of explaining of the thought process. I'm doing a lot of vocalizing things out loud that you won't have to do when you're doing the test. I'm just trying to walk you through steps that as you do more practice become quicker and more instantaneous. Okay? So don't give me that. Okay?